A big virtual hello to all of you listening to me at the FMKD workshop from India. So I am Mayukh Bagchi, a PhD candidate at the University of Trento in Italy, and today I am going to present an evolving work titled Representation Heterogeneity, done in collaboration with my supervisor, Fausto Junquillia. So I will start with the motivation of that work leading to the notion of representation heterogeneity, which is the core notion that we are proposing in the paper. And I will describe how representation heterogeneity is uh, recursively reduced to language heterogeneity and knowledge heterogeneity, each of which has their own unity and diversity phenomenons. Then I will provide a glimpse of how our layering of representation compares with prominent layering of representations of in the state of the art of knowledge representation, and then finally I will conclude by providing a glimpse of how representation heterogeneity is processed in practice. So semantic heterogeneity is a very well researched phenomenon and has been conventionally understood as the existence of variance in the representation of the same target reality when modeled by independent parties in databases. And the semantic heterogeneity has major consequences, such as the loss of semantic interoperability, but also more fundamentally, representational incompleteness and inconsistency. So in our work, we ask from the perspective of the latter consequence, that is representational incompleteness and inconsistency, we ask what is the general nature of the problem of semantic heterogeneity and how to provide a general process to resolve it. To that end, the current understanding of semantic heterogeneity as the existence of variance is very important and very necessary, but is not sufficient. Precisely because there can be no variance without a prior notion of a unifying reference taken as the basis on which the variance is manifested. So as a general solution, we propose representation heterogeneity, which is a more refined notion of semantic heterogeneity, capturing variance based on a unifying reference. So let me exemplify my motivations using an example of three small representative datasets in the domain of musical instruments. So the first dataset is from an online European musical instruments catalog, capturing the geophysical information about a chordophone. The second dataset instead is from an Indian museum, describing a stringed instrument in their inventory, and the language is in the Hindi language, and the first one was in English. Finally, the third dataset captures selling related information, that too minimal information, about a musical instrument and is from a factory, and is also the base language of this dataset is English. The question now is, are these three representations, are these of the same target reality, or are these different representations of the different target realities? So in the context of this example, while semantic heterogeneity would focus chiefly on the existence of variance in these three representations, we argue that there should also be an imminent need to decide on a unifying reference, maybe at a specific level of abstraction, based on like the purpose at hand, uh, on which such variance should be manifested or is manifested. And to that end, let us now briefly explore the underlying notion of world heterogeneity. So world heterogeneity in simple terms states that there are no two identical occurrences of target realities, whether same or different. Simply, no occurrence is identical to any other occurrence. And this phenomena is fundamentally perceptual and experiential in nature, and is really, if I may say, is unavoidable due to two specific dimensions. Firstly, the fact that it is impossible to construct a representation capable of capturing the infinite richness of the real world, even via the infinite ways provided by language to describe our world. And secondly, for any target reality, there will always be an aspect or an attribute which is not captured, and there will always be an alternative way to represent that particular aspect or attribute, or in general the target reality. Again, let me exemplify. And to exemplify, let us take some pictures of musical instruments from ImageNet, which is the preeminent benchmark dataset in computer vision. So if we only concentrate on the flasked block on the left hand side as a target reality, so for each of the pictures like wind instrument, and IL here means ImageNet level. So for wind instrument, string instrument, keyboard instrument, as well as musical instrument, it would really be like impossible to create a universally complete representation, even for instance within the scope of the English language for each of these instruments, as well as the other instruments that we can see in the other blocks as well. Further, for any representation of any of the above instruments, whether in this leftmost block or whether in any of these blocks, there will always be aspects which are somehow preferred due to purpose or perceptual viewpoint or level of abstraction, and thus generates alternative representations. So with this, we now arrive at our core notion of representation heterogeneity. So representation heterogeneity posits that there are no two identical representations of the same or different occurrences of a target reality. It is basically an omnipresent phenomenon. It's unavoidable and is grounded in the more general phenomena of world heterogeneity, which focuses on occurrences rather than representation of occurrences, which representation heterogeneity focuses on. So our proposal is basically to model representation heterogeneity in terms of the co-occurrence of these two sub-notions of representation unity and representation diversity. And let us very briefly see what these two terms mean in our context. So, representation unity explicitly models the fact that two different representations actually represent the same target reality. For instance, the target reality of musical instruments. And given representation unity, representation diversity models the ability of recognizing the mutual differences of the target reality. Like for example, again, the mutual differences among the different musical instruments of the target reality of musical instruments. let us see now concretely an example. So again, this is taken from the motivating example of the three musical instrument datasets that I already showed before. And we see really that the data value 2290 SDC50 is common to the first dataset, that is chordophone, to the second dataset as well, which is the stringed instrument of Tantuvadya in Hindi, as well as the third dataset, which is the musical instrument. And these particular data value 2290 SDC50, it populates the data properties like list number in the first chordophone dataset, inventory number in the second stringed instrument dataset, and the instrument number in the musical instrument dataset. And so we can somehow infer that this is an example of representation unity, and this is denoted in this picture by these small red stars. Instead, there are several distinguishing data properties. For instance, we can see for the first data set of chordophone, we can see that there are number of strings, which is 6 in value, as well as also we can see like the production, the place of production like India. For the second data set, we can instead see that there is a mention, there is a data property company, and the value of this particular property is Kala Bhavan. Similarly, for the third data set, we can again notice some distinguishing characteristics like inverse number, which is SDC 50.22. So these are some of the distinguishing data properties, and these drive home the factor of representation diversity, which is denoted in this particular illustration by small green stars. So from the motivating, so what we can really essentially observe is the fact that from a representational perspective, representation unity model the space of what exists across multiple perceptions of a target reality, such as, for example, the entity that we just saw, like 2290 SDC50 in the three representations, and the target reality being the domain of musical instruments, these three specific musical instruments. Whereas representation diversity model the space of variations across multiple perceptions of a target reality, such as the number of strings, I mean the company inverse number in these specific representations that was illustrated before. So these observations leads to the question how to establish the unity or diversity of a particular representation or of representations in general. Our approach proposes recursively reducing the problem of representation heterogeneity to the problem of language and knowledge heterogeneity, within each of which there is a constituent notion of unity and diversity. That is, we focus really on language heterogeneity, and within it language unity and language diversity, as well as knowledge heterogeneity, and within it knowledge unity and knowledge diversity. So from the perspective of the language layer, that is the language in which representations are expressed, the need for the co-occurrence of language unity and language diversity are primarily due to, let me say, two highlights. So firstly, different genus and differentia. So genus and differentia means like genus is the common part and differentia is the distinguishing part of the gloss of a synset. Synset is basically a set of synonyms denoting a particular lexical concept. And then secondly, the possibility of different conceptual hierarchies arising out of the combinatorial, the combinations basically of genus and different genus and differentials. And to that end, language unity models different concepts as different occurrences of the same common concept, such as for example guitar and koto are both stringed instruments, and stringed instruments being the genus of both of these guitar and koto. Given language unity, language diversity then models the differences between them. So for example, guitar and koto having different differentia while having the same genus, that is stringed instrument. So basically guitar and koto have different number of strings which can be considered as a differential. And similar to that of language that we just now saw, the need for co-occurrence of knowledge unity and knowledge diversity in the knowledge layer are primarily due to, firstly, the different data properties which intentionally describe particular target reality, and given that the different data properties values which populate them. So we thus have knowledge unity which recognizes two different entities and different occurrences of the same common entity, such as for example list number, inventory number, and instrument number, all of which are at the value level 2290 SDC 50, as we saw in the previous example of the three data sets of musical instruments. And given knowledge unity, knowledge diversity recognizes a difference between the entities, such as in particular representation, the number of strings had the data value as 6, whereas for the other representation, the value of the company was Kala Bhavan, and so on. Like the inverse number for the third representation was SDC 50.22. So now if you have noticed carefully, there is a clear layering of representation in the approach that we propose to resolve representation heterogeneity, and that we have seen so far. So we now position our layering of representation with Brackman's proposal for layering of representation, and which was later refined by Nicola Guarino by adding an ontological level dedicated to meaning and satisfying meaning postulates in between epistemological and conceptual layers which were earlier proposed by Brackman. Instead, our layering, which you can see in the lower left hand side of your screen, comprises of conceptual level, lexical semantic level, schema level, and data levels, of which the first two, that is conceptual and lexical semantic level, cumulatively tackles the language heterogeneity, and schema and data level cumulatively tackles the knowledge heterogeneity. And this kind of layering of representation is really orthogonal to the one above proposed by Guarino, because our representation focuses really on representing the world inside, and in such a fashion of representing the world that it innately deals with representation heterogeneity. and also thereby it implicitly proposes a knowledge engineering process which is natively grounded in representation heterogeneity, whereas Brackman and Guarino's layering more or less focus on the knowledge engineering process by which one can generate a certain model of reality. So we now briefly illustrate how our layering of representation translates into a stratified process dealing with representation heterogeneity. So let us think of input as the three musical instrument datasets. In each of these datasets being in same or different natural languages, we can even consider the three datasets that we saw in the motivating example before. So firstly, at the lexical semantic level, we extract and map the semantically similar scene sets across the different languages of the input datasets and assign a unique a-linguistic or supralingual ID to each of these scene sets. So for example, if you have noticed, if you remember the dataset, so we had chordophone which is mapped to, which is chordophone musical instrument. These belong to a particular classification scheme of musical instruments or classificatory language of musical instruments, which here, I mean, it's not the focus, but which you can see abbreviated as HSC. Whereas there is another kind of classificatory language, domain language, which is like PWN. So you can see that these two scene sets are being mapped and matched, like stringed instrument with chordophone, musical instrument with musical instrument, manufacturing date and date, instrument number and list number. These are semantically mapped. And each of these, again, each of these scene sets are assigned an a-linguistic ID, like as you can see on the screen for stringed instrument and chordophone, the common a-linguistic ID is 15045. For musical instrument, for instance, it's 65249. Then at the conceptual level, we organize the a-linguistic concepts into a directed acyclic graph DAG, and this DAG encodes the space of all possible conceptual hierarchies. As you can see here, these GIDs that we have, these are now organized into conceptual hierarchies. This is just a very small fragment just to demonstrate the process. And this particular structure that we get at the conceptual level, we call it a language entity graph. So these two blocks, like lexical semantic or levels, like lexical semantic level and conceptual level, these two blocks collectively define the choices of language unity and language diversity that we earlier proposed at a more high level or at a theoretical level. Then moving on to the schema level, we model an a-linguistic entity type graph at this level, and we do it via an intentional definition of data properties like 15045, which is, as we can see from the lexical semantic level, it's a stringed instrument or a control. It is further intentionally defined with the properties like 34577, 232, 2367 and 36654. Each of these which are also concepts at the conceptual level. And lastly, at the data level, the entity type graph is again populated with data property values. I mean the data properties which intentionally define this particular entity at the schema level. These are populated with data property values, and thus at the data level we get what we call as an entity graph, which is essentially a knowledge graph. And these two blocks, like the schema level and data level, collectively define the choices of knowledge unity and knowledge diversity that we had proposed earlier. Finally, the knowledge graph is returned to the language, but it is returned via the lexical semantic language level, so that the user can get the knowledge graph or can visualize the knowledge graph in his or her preferred language. By the way, this process that we have presented here is not possible, or rather impossible, without what we call as the Universal Knowledge Core, or UKC. So UKC provides this is basically the background knowledge provided by, and then UKC is essentially a multilingual lexical semantic resource. It has just a few facts about UKC. It has over 2 million words in over 1,000 languages, having 100,000 lexical concepts linked via around 8 million, if I am not wrong, lexical semantic relationships. And the essential structure of UKC is that it is divided into two components: LC, which stands for language core, and CC, which stands for concept core. So language core is dedicated to codifying natural language and domain language semantics via synsets, which are linked to each other. So you can see in this diagram, this is more or less aligned with the motivating example that we saw of the three datasets. So here we have like three domain languages. So one is from the European classification scheme of musical instruments. Then another, the Natya Shastra, is basically an Indian scheme of classifying musical instruments, and another one is from Princeton Wordnet. And each of these synsets like chordophone, tantuvadya, and stringed instrument, these are interlinked to each other. And if there is no equivalent concept in a different language, what we have is called in lexical semantics as lexical gaps. So this is the composition of language core, composed of different domain languages as well as natural languages, and it is expandable. And then these synsets, which are interlinked to each other, are hierarchically organized via their linkage to alinguistic or supralinguistic identifiers in the concept core. And as you can see here, for instance, 15045 is basically the alinguistic identifier for the concept of chordophone, tantuvadya, as well as string instruments. Similarly, 789066 and 159789 is for koto and esraj. And these are again organized into hypernym and hyponym relationships. And we really exploit this UKC heavily in the representation heterogeneity process that I illustrated before, at all the steps, but especially in the first two steps. Thank you for listening to my presentation, and I would be happy to receive any valuable suggestions. Thanks.